with the examples for multiple memory access instructions. In the previous session, we have learned the operations of different multiple memory access instruction. Today, we will again analyze the same operation with different examples for multiple memory access instruction. So under that, let us now start with the load instruction, load multiple register. So the mnemonic here is LDM. For loading multiple registers, it is load M, LDM. We have discussed that we can have 4 different addressing modes here. One is IA, that is increment after. Second one is IB, that is increment before. Third one is decrement after, DA, and fourth one is DB, decrement before. So it can have along with the mnemonic, it can have a suffix, 4 suffixes, IA, IB, DA, DB, or we can call it as the addressing modes, that is IA, IB, DA, DB. So first example we are considering with the suffix IA. LDMIA are not comma within brackets the register list. We have seen the syntax for this instruction. LDMIA are not comma within the flower brackets we have the register list. It need not be always 3. It can have R0 to R12 registers. So what is load operation? Load operation is the transfer of data from loading the data from memory to the register. So you have the register list here, memory to the register. So where is the memory address source? So it is present in the R0 register. Generally we call this as RN, that is R0 register. So here R0 will have the memory address. From this memory address, each data from the memory location, this memory location will be moved to the register list as shown in the or given in the instruction. So we have 2 types of representation of the same instruction. LDMIA R0 comma R1, R2, R3, or you can represent the same instruction as LDMIA R0 comma within flower bracket R1 to R3. You can represent in this way only if the registers are in continuous. Like see here, there is no discontinuous in the registers, that is R1, R2, R3 are continuous. So when you have a register list which is continuous, then you can just represent R1 to R3. Suppose you say, if you consider an example of LDMIA R0 comma R1, R3 and R4. Suppose this is an example R1, R3, R4. Is it continuous? No, this is not a continuous set of registers. So you cannot represent in this form when the registers are not in continuous. So as these are in continuous, I can either use this or I can represent the same instruction in this way. So this is 2 types of representation. Now increment after, we have discussed that we have certain formulas for finding the starting address and ending address. We have discussed the same in the previous session. So I have represented the same here. For increment after, we have start address as Rn and end address as Rn plus 4 into n minus 4, where n is total number of registers in the register list. Okay, now we will analyze the operation of this instruction. So from where to where the data will be loaded, from the memory location to the register. So what do you need first? You need the memory address. So where it is present? It's present in R0. Now let us see. Before execution, what is the content of R0? R0 is having 0x10 and R1, R2, R3 are having 00, 00, 00. So we have R0 as 0x10. Now this is the memory address. Again, I am repeating, R0 is a 32-bit register. For simplicity, we are representing in this way. Actually, it will be preceded with the zeros. So totally it has 8 digits, that is 32 bits. Okay, so now what is the memory address given here in R0? It is 0x10. Now let us find where is that address. So it is pointing to the memory address 0x10. From where to where you need to load the data? You need to load the data from the memory to the registers. So what is present in this memory location? What is the operation? Load multiple registers, increment after. What is the first operation? You have to first load, then increment the address. So what you need to do first? First, whatever the data it is pointing with this memory address. What is the data? It is 10. So 10 will be first loaded into R1 register. 10 will be first loaded into R1 register. Later it will be incremented. It will be incremented by 4. Why it is 4? Because 10 is a 32-bit data. We are considering every data as a 32-bit data. As we have 32-bit data here, it occupies 4 memory locations. Therefore, 10 plus 4, here it is 14. Okay, 10 plus 4 is 14. Therefore, next memory location will be 14. So first it is loading the data from this memory address to register R1. Then it is incrementing. Increment after. Now, what is the data present at this memory location? It is 20. Now, 20 will be loaded into register R2. Later, it will increment. Increment in the sense, it will add plus 4 to this. So, 0x018 will be the next memory address. So, what is the data present at this memory location? It is 30. Now, 30 will be loaded into register R3. It is in series, right? So here you have R1, R2, R3. In the same order, the data will be loaded. Now, as you have 3 registers here, 3 datas will be loaded into 3 register. Now, after loading the last data, what is the suffix you have used here? Increment after. So after loading the last data, the memory address will be incremented, and finally it will be pointing here. Okay, now this is the operation. Now after execution, as you are seeing, R0 is having 0x10 only, but according to our operation, where the memory pointer was pointing to, it was pointing to 01C, but this is not updated in register R0. Why? Because here you don't have an exclamatory mark. Suppose you had an exclamatory mark, then what was R0 content after execution? It would have been 0x01C. As there is no exclamatory mark here, then R0 will not be updated. It will retain the same value as it is. Did you understand this? I hope everyone have understood this operation with the suffix for the instruction LDM with the suffix IA. It's better to remember this formula so that it will be easier. Now, we have analyzed according to the operation of IA. Let us now cross-verify the same addresses, start address and end address with this formula. Where did we start the data from? We started from here and ended till here, right? So let us analyze whether we get the same addresses with the formula. Now, what is the start address for IA? That is suffix IA. Start address is RN. What is RN here? In our example, RN is R0. Where R0 is pointing to initially, it is having 0x10, right? So that is the starting address. Starting address is here. So first data will be loaded into register R1. Did you understand? So the data starts from this memory address. Now, where the end address will give you, what will be the end address? So end address will be given by this formula, Rn plus 4 into n minus 4. What is n here? N is 3. 3 is total number of registers in the register list. So 4 into 3 will be C, 0C. So Rn is initially 0x10. So 0x10, 10 plus C minus 4, that will give you 18. So that will give you an 18. So from here, that is from address 0x010 to 0x1018, the data will be loaded into the registers. So if you remember the address, it is direct. Just calculate this from here to here, transfer that to registers. That's all. That is simple point actually. So based on the increment after the last data is being loaded into register, the memory pointer will be incremented and it will be pointing here. Suppose if it is if there is an exclamatory mark, R0 will be updated with this address. Suppose if there is no exclamatory mark, R0 will retain the same address. Okay, so this is the operation of instruction LDMIA. Now let us go for the next instruction. Now, the syntax for the next example is LDMIA RN exclamatory mark, comma, register list. So I told you already what happens when you have an exclamatory mark here. So let us see with an example. So we have an example LDMIA R0 exclamatory mark, comma, register list. So in the register list, we have R1, R2 and R3. So now what is initially R0? R0 is 0x100. So always this has the memory address. Now what is load operation? Load operation is data loading from memory to the registers. So where is memory address present? Memory address present in R0. So what is the data present in R0? That is the memory address present in R0. It is 0x100, which is completely a 32-bit data, which will be preceded here with the zeros. Okay. Now, where that is pointing to, let us look into the memory location here. Okay. From memory location to the register, it has to load the data. So this is initially pointing to 0x100. Let us start with the analysis of the instruction LDMIA. So what's the operation? What does it say? First load, increment after. Okay, initially it is pointing to this memory location. First you have to load from this memory location. What is the data present in this memory location? It is 10. So 10 will be loaded to the first register R1. Later increment the memory address. Now it will increment the memory address and it will be pointing to 104. Okay, what is the next data present in the memory location? It is 20. Now 20 will be loaded into which register? R2 register. Okay, after loading, what you have to do? Increment the memory address. Now memory address will be pointing to 0x108. Now what is the data present here? It is 30. 30 will be now loaded to the last register R3. Okay, now loading operation is done till here. But what is the suffix saying? Increment after. So memory address will now increment and point here. Okay, as you have only 3 registers, 3 datas are loaded and memory location address will be increment and it will be pointed here. Okay, now as you have an exclamatory mark here, what will be the content of R0? R0 will be 0x10C. Okay, so it will not be the same address. It will be automatically updated because of this exclamatory mark. In the previous example, we did not have an exclamatory mark, therefore R0 had retained the same value. But in the next example, we have an exclamatory mark, therefore R0 content will be automatically updated to this memory location. I hope everyone have understood this instruction operation. Next, we will look into the next instruction. Okay, next we will look into the next instruction LDMDB RN exclamatory mark, comma, followed with a register list. So here we have considered an example LDMDB R0 exclamatory mark, comma, register list has R1, R2, R3 registers. Now the operation of LDM along with suffix DB can be found out by the starting address and ending address formula as given here. So starting address is Rn minus 4 into n. Ending address is Rn minus 4. So according to this example, Rn is register R0. So initially before execution, R0 we have considered it as 0x024 and the content of registers R1, R2, R3 are 0, 0, 0, 0, 0, 0 respectively. And R0 is register content will be 0x24. So now initially R0 is pointing to this memory location. Now you have to remember the suffix. Suffix is DB here. When you have decrement before or decrement after suffix, you have to take care. Now it is better if you calculate the starting address and ending address. Now let us calculate the start address and the end address according to the formula. What is Rn content? Rn content before execution, that is R0, is 24. 24 in hexa. 24 minus 4 into 3, that is 12. So 4 into 3 is 12. That is nothing but 0C. So 24 minus 0C will be 0x018. That is the starting address. And ending address is Rn minus 4. So Rn minus 4 is, that is 24 minus 4. That will give you the end address as 0x020. Now you have found out the starting address and ending address. So now let us mark this. So this 0x018 will be the starting address. 0x020 will be the ending address. That means these many memory blocks will be moved to the registers R1, R2, R3. But where is the memory pointer pointing to? It is pointing to the address 0x024. Now the operation has to start from this address itself. Now what is the suffix? Load memory decrement before. Okay, so before loading you have to decrement the memory address. So let us now first decrement this address. Now for the first decrement, where it will be pointing to? It will be pointing to the address 0x020. What's the content present here? The content present here is 50. So 50 will be first loaded into the last register, that is R3. Okay, now again you have to decrement, then the memory address will be 0x01C. The content present in this memory location is 40. So 40 will be now loaded to register R2. Now before again loading, you have to first decrement. Decrement, now the memory address is pointing to 0x018 and the content present in this location is 30. 30 will be now loaded to register R1. Now as all the datas, all the registers have been loaded from the memory location, it will not decrement further, it will stop the operation. So where R0 is now pointing to? R0 is now pointing to 0x018. Now as you have an exclamatory mark along with R0 register, so R0 will be automatically updated to the memory location address 0x018 that is given here. So this is the operation of the instruction LDMDB Rn exclamatory mark, comma, followed with the register list. Okay. Now we have same suffixes in the instructions store. So we have 4 different variations in the store instructions as well. Now what is store operation? Store operation is storing the data from register to memory, from registers to the memory. In load it was the reverse, from the memory location to the register. In store instruction it is from registers to the memory. Okay, now let us start with the single instruction with the suffix ia, increment after. So in increment after, let us see the instruction STMIA R9 exclamatory mark, comma, within brackets R0, R1, R5. So here the registers are not continuous. Therefore, you cannot write R0 to R5. You have to specify individually in the instruction. Now let us see the operation. Before you start the operation, remember store is from register to the memory. Register to the memory. So what is the first register here? First register is R0. So from R0, it will directly store the data to this memory location address, which is pointed by R9. Okay, then you have the next register, R1 register. Then the R1 register content will be loaded into the next 4 memory locations, after next 4 memory locations pointed by R9. Last will be the content of register R5. Okay, now let us analyze the same. Assume that initially R9 is pointing to this memory location address, that is 100C. 100C. So initially what does it say? First store, then you have to increment. So first store R0 content to this memory address. So R0 content is being stored directly to this memory address. Okay, next Next, after storing, it has to increment. So first it will store, then increment. Okay. Then what is the next register? R1. So first next it will store R1, then it will increment. Next it stores R5, then it increments. Now what is the updated address in the R9 register? R9 after execution of this instruction will be 1018 because R9 is followed with an exclamatory mark. Okay, so this is the operation of STMIA instruction. Now, in suppose if there was no exclamatory mark in that instruction, what will be content of Rn after execution? It would have been the same address 100C. As you have exclamatory mark, the address will be updated as 1018. Okay, now next we look into the next example, STMIB. Rn exclamatory mark followed with R0, R1, R5. So what it is what it is saying, what is the operation of this instruction? Store increment before. Okay, so store increment before. That means you have to first increment, then store. You have to first increment and then store. Okay. Now, what is the first register to be stored? And before that, what is R9 pointing to? R9 is pointing to this memory location address 100C. So what is this operation telling? You have to first increment, then store. Okay. So you are incrementing, then storing. Okay, that is the first register R0. Then incrementing, then storing. Incrementing, then storing. What did you do here? First you stored, then incremented. You stored, then incremented. Stored and incremented. But here what you are doing? You are first incrementing, then storing. You are incrementing, then storing. You are incrementing, then storing. Okay, so all these three datas have been stored now. You are not incrementing again because already that operation is being performed. Okay, so what is updated R9 address now? As you have exclamatory mark, R9 will be updated with 1018. Okay, so this is the operation of STMIB, R9 exclamatory mark followed with the register list. Next, we will look into the next example, STMDA, that is decrement after. You have to decrement after storing. Okay, so R9 exclamatory mark followed with R0, R1 and R5. Okay, so first it will start whenever you apply the formula for DA and DB. You have to take care of the operation with the DA and DB. So initially R9 is pointing here. R9, what does it say? Decrement after storing, right? So initially R9 is pointing here. So what is the last register available here? Available register here is R5. So it will start with the reverse. Okay, R9 is pointing here. R5 will be stored, then decremented. R1 will be stored, then decremented. R0 will be stored, then decremented. So what is the latest memory address pointed by R9? It is 1000. So after execution, R9 content will be 1000. So before execution, R9 content will be 100C. Okay. Next instruction is STMDB, R9 exclamatory mark, comma, followed with R0, R1 and R5. So initially R9 is pointing to address 100C. So what is the first register which is being stored? It is the last register R5. So first it will decrement, then store R5. Decrement, then store R1. Decrement, then it will store R0. So updated R9 content will be 1000. So as you have exclamatory mark, R9 content will be changed and updated to 1000. Okay, so these are the operations for load and store, multiple load and store instruction along with the suffixes IA, IB, DA and DB instructions. Now let us see overall instructions of LDA and LDM and STM. So this gives the complete list of LDM and STM instructions available. So we have the first instruction already we have discussed. We will not repeat the same. We will just look into, there are 2 points which has to be noted from this slide. Okay, so I'll tell that. So LDMIA RD exclamatory mark register list. We have analyzed what the operation of this instruction is. Okay, and whenever this instruction is used, this representation indicates that this type of instruction is under 16-bit thumb instruction set. Okay, 16-bit thumb instruction set. So we have 3 different types of instruction set. One is 16-bit thumb instruction set. Then you have ARM instruction set, 32-bit ARM instruction set. Next you have thumb 2 instruction set. In thumb 2 instruction set, you can either have 16-bit representation or you can have 32-bit ARM representation, right? So whenever you use such representation of instruction LDMIA, by default it will consider this as a 16-bit thumb instruction set. Okay, similarly you have the next instruction as STMIA RD exclamatory mark register list. So here it is store multiple registers with the suffix increment after. So again, this will be considered as a 16-bit thumb instruction set. Next, you have LDMIA dot W RD exclamatory mark register list. Please compare the third instruction with the first instruction. This is the point you have to note down. The first instruction and the third instruction. What difference you can observe from first instruction to third instruction? When you compare these 2 instructions, there is no suffix, the extension of suffix here with the dot W, whereas you have dot W here. So dot W specifies whenever you are using the same syntax in a thumb 2 instruction set, you have to represent it with the dot W suffix. So whenever you use dot W, this will be considered as an 32-bit thumb 2 instruction set. Again, I'm repeating, this is just the representation of the instruction code in the memory. Okay, it means that it does not mean that it is working or operating on a 16-bit data. Definitely all the registers, all the instructions will be operating or working on a 32-bit data only. But 16-bit thumb instruction set, 32-bit thumb instruction set, thumb 2 instruction set, it means that the compression form of the representation of the instruction code in the memory space. Okay, now you have one more instruction LDMDB.W. We have already seen the operation. So what does .W indicates? .W indicates we are representing the instruction in 32-bit thumb 2 instruction set. Okay, next similarly you have STMIA.W RD exclamatory mark register list, STMDB.W RD exclamatory mark comma followed with a register list. Now I told you that we can observe 2 points from this slide. The first point is that from these 2 instructions, the first and third instruction, you can observe that these syntaxes can be used. The syntax is same here, right? The syntaxes can be used with some extension. It can differentiate from 16-bit thumb instruction to 32-bit thumb 2 instruction just with the suffix, inclusion of a suffix here. That is the first point. Second point is, if you just observe the exclamatory mark, if you just observe the exclamatory marks here, in 16-bit thumb instruction set, it is compulsorily exclamatory mark has to be used. Okay, as shown in the syntax. In the syntax itself, the exclamatory mark is there for the that is the memory pointer register. Okay, whereas in 32-bit thumb 2 instruction set, that is these 4 instructions, can you see the exclamatory mark which is represented in a single braces? So here it means that you may use this exclamatory mark, or you may not use the exclamatory mark. Okay, it is left to the choice of a programmer whether to use this exclamatory mark or not. So that option is there only in 32-bit thumb 2 instruction, not in the 16-bit thumb instruction. In 16-bit thumb instruction set, by default, RD will be updated after execution of the instruction. So this completes the instructions under just memory access instructions, that is just load and store instructions.